one linear programming, just like what you did in CX Maxa. That linear programming, same thing. Assignment models, that's like a Hungarian algorithm. You have graph theory, CPA, critical path, and logic and boolean. Right? Since we now starting today, we will start with logic and boolean algebra. Okay. To save yourself from writing, I will send you. I'll probably send you the same thing, right? So you don't have to write all of this. Okay, so let's start with Boolean algebra one time. We'll go over the gates. Right? You would have done this in pure maths, kinda. You'd have done physics as well. Right? Let me see. Any non-physics people here? For physics. Everybody do other physics something. Right. Anybody here never did physics? Right. So the first thing we have to remember our logic gates. Right? In your logic gates, you have to remember your AND gate, OR gate, XOR, NAND gates, NOR and XOR, right? So you gotta remember like the summaries and all the gates, how they behave. Right? So for example, the AND gate, 2 1s giving you 1, everything else is 0. So you have to learn it like that, right? The OR gate, you'll always get a 1 except when you have 2 zeros. XOR, once the inputs are opposite, you'll get a 1. Right? NAND gates, 2 1s will give you in fact, you don't want to learn NAND so much because NAND is just the opposite of AND. XOR, right? The NOR, sorry, is the opposite of the OR gate. Okay? And XOR is the opposite of the XNOR, sorry, the opposite of the XOR. So once you learn the first tree, the bottom tree is just the opposite. Right? Nice. I don't know if everybody did pure math, so I'll go over this. So whenever you have an AND gate, right, an AND gate could be represented by something called a conjunction. So if I give you 2 inputs, P and Q, to represent it, it can be done like this. P and Q, written like that. Okay? So if I ask you to take a AND gate and represent it using a logic gate symbol, sorry, using a Boolean algebra, it will be P and Q. The OR gate will be P or Q. Right? We know them as conjunction and disjunction. Okay? Jaden, you okay with that? Jaden? Okay, nice. And then we should know about the NOT gate, right? The NOT gate is always given the reverse. So the NOT gate there, the NOT gate, we call it negation. So the NOT gate always negates what you have. So if you had a P initially, just negate P. And that will be the NOT gate. So we had to learn to represent them using Boolean algebra and how to represent them using circles. Right? If you look underneath here, we have to learn the truth table for conditional and biconditional. Conditional means P implies Q. Biconditional means P if and only Q. Okay? So we are learning truth table. Mine's kind of split up in 2 there. Hold on, Let me just send all the same data right. right? So you have it there, right? So you don't have to write this. You don't have much writing to do, it's just practicing your book. Right. Conditional is always true, except when true implies false. That's the only time a conditional statement is false. Right, sorry. That's the only time a conditional statement is false, right? You'll see me all the right. I want to know how you'll see this thing. Right, see the correct one. Nice. And for biconditional, when the truth values are the same, you'll get true. If they are opposite, then you'll get false. So if we have P implies Q, the converse, we flip them around. Inverse, we put negation in front of P and Q, and the contrapositive, we flip it around and then find the inverse. And then put in negation. So for example, if I gave you the statement Q implies the negation of P, and I said, well, what's the converse? All we have to do is flip them around. So you'll get the negation of P implies Q. Right? So you're just switching them around. If I said what's the inverse, all we have to do is negate the original thing. Huh? You negate Q and you negate the negation of P. Right? You may or may not know, but if you negate something, it double negate, it cancel off. So your final answer is the negation of Q implies P. All right, Darian, you okay with that? And to find contrapositive, all we have to do is flip them around. Right, flip around the inverse. Right, flip around the inverse, so you'll get P implies the negation of Q. Right, and we'll give you a little note there on what is tautology and what is contradiction. Questions? Let's make sure you're good, right? No questions? All right. Let's just try one now. Right, the algebra is the hardest thing, right? I'll do some of that on the board. Actually, wait. Before I show you, let me just show you switching circuits one time. Switching circuits real simple, right? Sometimes in applied maths or in maths, you want to represent logic gates using actual electric circuits. So what they recognize is that if you have switches in parallel, it represents or behaves like an OR gate. If you have switches in series, they behave like an AND gate. Think about it, right? For the AND gate, right? The only way this bulb here will light up is if both switches are closed. Both of them must be closed. That's the only way the bulb will light up. If one of them on and one of them off, that bulb will never light. So that is the way an AND gate behaves. Okay? So this one is considered lighting or not lighting. All right? And that's all. Of course, it wouldn't be that simple. Huh? They'll combine circuits like this. Tell me how you think they will write this. How you think they might write that using Boolean algebra? Boolean notation. Now we have to type now. Or they can type that, man. Type it down. I'm gonna see what they get. Anybody? I'm going to have the message. Oh, I just sent something. I correct Christian. Jesse, right. But you have to use the notation, so that's really good. So this is an OR gate, right? Good job, Damien. You have it back to front, right? But you're close to it. You mix up the symbols. Remember, OR is this, and is this, right? So this is QOR and P. Okay? All right, good job. Look, Darion, sending something. All right? So very good. And of course, we had to be able to do the reverse, right? We had to be able to move from here back to here. All right, so we're going to practice some of that. All right, let's jump to some of the papers. Don't forget my graph paper tomorrow next week, okay? Sorry to get a hard one time, but see if you could determine the Boolean expression first. I'm gonna just give you one little hint, right? I ain't doing too much here. Here's P. Here is the negation of Q. So it means that here, because it's an AND gate, it will be P and the negation of Q. See if we can finish out all the rest and figure out S. Right? Just tell me you finish, right? Don't know set this one, kind of low. Right, nice. Somebody finish all your Vietnam Jira. Right, let's see. Right, so I gonna. So here will be P. So here will be P. Here will be the negation of R. So here will be P and the negation of R. Now we're going to put them together. These are all gates. So the final answer, writing it down here, will be P and negation of Q, P and the negation of R, and you're pouring all of it. Okay? That's the first one. Let's go again. So the second part is what's that? Christian, hold on. So the second part is, isn't it Q and the negation of R? Oh, no. Watch Christian. The problem here is this, right? Remember, it's starting here. So the one that's feeding into here, P, not Q. Really and truly, the diagram should have a little loop like this. But they don't loop it because it's showing you where it's coming from. So it's really P and the negation of R. That's okay? Yeah? All right. Try this next one here. Do the truth table to prove it. Don't worry with the boolean algebra. I'll show you that next thing. Let's just focus on it. Or later one. Do this, please. Okay, then again, true. Yeah, so far. Okay. Right? Let's do it via truth tables first. Take your time and set it up, right? Oh, by the way, remember, check how much variables it have, right? If it's one variable, so for example, here's what I'm saying, right? If it's one variable, you will just have two options, right? If it's P and Q, then you will have two, then you will have four options. If it's P, Q, and R, then you have eight, right? So you see how I'm going true, false, then two true, two false. Here you will go four truths, and then four false, and so on. Okay. Anyway, we only have two options here, right? We have P and we have Q. So I write in the truth table part of it here. Right? Then we need to get negation of P. I write small, right? So I'll put all of it. We'll look out for that now. All right. So I'll do these first and then I will do the or and the and, right? I will try to fit it on the outside here, or and. Right? So the or is this one and the and is this one, right? So negation of P, that'll be false, false, true, true. Right? Just negate everything, right? For the P. Now negate everything for the Q. So that'll be false, true, false, true. Right? So you're just negating everything. Now, P and the negation of Q. So I'm looking at P and I'm looking at the negation of Q. I'm looking at those two, right? And I'm using the and. So that'll be false, true, false, false. Now we're looking at not P and Q. So that'll be false, false, true, false. Now we're looking at P or Q, or now, right? So that'll be true, 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 false. And then I'm looking at negation of P or negation of Q. That'll be false, true, true, true. Right? That's the first part of the truth table. Now I'll come in here. And I'm going to try to find the long part here. P and negation of Q or negation of P and Q. So that would be O, right? So that would be false, true, false. False, false, true, true, false. Right? So that'll be false, nice. Then the next two will be and. So that'll be same thing. So therefore, since these two columns are the same, since all the truth values are the same in those columns, then we could conclude that they are logically equivalent, right? So this is the same as this, so therefore logically equivalent, right? Questions that we show the equivalent. Copy down. Any questions? So you gotta learn about those two tables, right? Yeah, learn it truth table. Right, next one. You want to switch in circuits for those? Take your time. If you see a negation, instead of write, so it's like how we had a switch like this, instead of writing P, just write negation of P. That's all, right? Try that first. Just tell me when you finish, I'll do it, right? And guess when you finish, right? All right, that's one person finished, two people finished. All right, nice. So let's see, right? So the first thing I see in here is a O. So that means it's going to look like this. Right? And then I see an and in here. So that'll be P and the negation of Q. Inside here will be the negation of P and Q. You agree with that? Right? That's the first one, right? In case you didn't get a second one, try it quick. Start with here, right? So you know it's an and. Right? So let's see what you have. Yeah? You agree with that, Darian? You agree with this one? Darian? Yeah? Okay. Anybody confused with this? Last part. I think I gave you this already, right? Yeah, I gave it that already. Try A and B. And then we have C and D. Try the whole thing actually. Except part E. Right? Let's actually finish off that, right? Darian, you working? Okay, I hope so, eh? Oh yeah, take a 10 minutes and do that for me now, please. The finish message okay, right? After pressing finish, right? Oh my God, good day, boy. Anybody done? Nice, one person done. Hurry up. Come on, you finish, Mr. I want to finish, Mr. Darian. I waited on you, boy. Right, let me see if Darian. Ooh, Darian didn't say nothing, but Darian, I'll be able to start it now. Yeah, but you didn't tell me you're done. Oh, I was know you're done. All right, I'll give you enough time. Let's correct it out now. Right, so the first one in words. I asked you to tell me you finished, boy. Anyway, the first one in words will be he is not tall and he is not happy. Okay? So he is not tall and he is not happy. Next, determine the truth value of the statement. London is in London is in New York, or 2 times 3 is equal to 5. Okay, so this is a or. So for something to be for at this junction, right? For it to be true, all has to happen is that at least one of these statements here must be true. Okay? So when you think about it, London is in England. That's true, right? And 2 times 3 equals to 5. That's false. True or false will be true. So the answer for that is true. Y'all okay with that? Y'all okay with that there? Yeah? Okay, nice. Next one, by constructing a truth table, determine whether it's a tautology or contradiction. Okay, so let's do a little truth table for that. P, Q, P and Q, P or Q, P and Q implies P or Q. P and Q implies P or Q. All right, so nice. So this is true, true, false, false, true, false, true, false. Right, so and this will be true, false, 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 or this will be true, 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 false. Right, and now conditional, there is no true or false, so every single thing here is true. So therefore is a tautology. Tautology means every single thing is true. Nice, Jesse, good with that? Yeah, okay. And last one, sorry, last part D. I'll take it obvious now, right? Right, last part D. A and B or, so it's an or, so it'll look like this. Or is the main thing, right? There's or in between 2 ands. Okay, so we have A and the negation of B, or, oh wait, no, only was a C. What kind of thing? Well, yeah. I'm gonna try it a little bit neater. So I'm doing the first one, A and the negation of B. That's the first one, right? And the next is A or C. So I'll come like this. Negation of A or C and B. Nice. Look at that, Darian. You got that? Check it back and see all this together, right? Dariun, you good at boy? Yeah, boy. You good at boy? Yes, sir. Okay. Say yes, sir, too. Nice. Christian, you're okay? Damian, are you okay? Right? And last part, what they asked for in this last part here, right? They wanted as a logic circuit using only and or not, right? Negation of A and A or B, right? So the overall, it looks like an AND gate, and then A being fed into NOT gate, right? That will give us the negation of A. And then, oh, we have B, squeezing in my B here, right? B is connected to OR gate. Right, that's what I'm about. Right, that's A or B, right, going into this gate. So now I have the negation of A and A or B. That's it. That's how we get there. Right? So that's the way you have the questions like this. Right, the next thing I have to show you will take a little bit more. All right, next one. Do we have time for one more little piece there, buddy? Hold on, huh? So the only thing that we have to do really is the algebra part of things, right? So I wouldn't rush the algebra thing, but what I want you to do, right? What I would like you to do, to really be nice if you do it. Really, really nice. Really, really nice. If you could spend some time, because most of you all did pure maths here, right? If you could spend some time and right. If you could spend some time and learn this summary. See, so you see what I will do is that will reduce, that will allow us time to practice a few. So you have to go back over and learn these laws. You need the laws, right? So whenever you see P, so for example here, whenever you see P and true, you know that's always P. P or false, you know that's always P. P controls it, right? You don't really have to know the name so much, but some people like it to use the name. But if you use the rules properly, the names don't really matter, right? But some people like it to write it and write the name as well. But because has memorizing the name, just learn to use the rules properly, right? So what I want you to do is we can spend some time between now and next week, that's a whole week. I know you have other things to do, but we can spend some time and just run through the loads. Because the only thing that really hard in this topic, probably this module, is this. This become a little tricky. Right? So I want you to try a few from revise it and then we'll try a few. All right? I wouldn't rush it down today because I want us to practice. So for homework, if you can just learn the laws. Right, Jaden, you can handle that. I just learned the laws, all right? All right. All right, we'll stop there then. We'll stop there and we'll continue from here. You also need graph paper for next week, please. We're doing this and the graph paper one time next week, right? It's the same thing like you would have done in C-Sec Maths with linear programming, and you have to draw a line and shade above the line or below the line. All that hard in Unit 2 is that you have to be able to figure out the inequalities. It's a little bit harder. It's not as straightforward. Some of them not as straightforward. You have to figure out the inequality.